already did the mole map.
Yeah.
Mole map, it explains how to get from and to and from moles. On the back side of your paper, we're going to have multi-steps, so you'll have to get from one spot to the next using moles. But we'll just start with this one to begin with. If we look at silicon, okay, so what we have to do, we have to get to moles. We have our grams, but we have to figure out what our molar mass is in order to get to moles.
We have to divide it.
We have to divide it.
I don't have that freaking problem. I made him out of it.
You're all on the wrong side, but it's okay.
What's your problem?
So silicon is SI. We look for SI. Anybody can tell me what the
28.08.
28 point what?
08.
So 28.1 plus hydrogen 4. So hydrogen is 1, but you multiply that by 4, and that gives you 4. So you have 32.1. So you'll divide this number by this number to get your moles, and the answer is? Yeah, but 43 divided by 32.1.
Oh my god. Divided by 32. It goes 1.3.
1.3 moles. If you'd like to put the E on the end, you're more than welcome to. If you freckles won't necessarily get you credit because that it means nothing.
If she puts her payments corny on a paper, can she put freckles on it?
I mean, she can always do whatever she wants to her name, so that's fine. Alright, we have done moles to mass and mass to moles, so let's go with something new. Would you rather do
Moles to
particles, or would you rather do volume? Both? One of each? Alright, so let's go from HCl is easy, so hydrochloric acid. We have 12 moles, 2 atoms, which is molecules in this case.
Is that 0?
No, we're just trying to figure out what that number is. So if we look at our molar map, particles is represented by Avogadro's number. So if we're going from moles to particles, we multiply it by Avogadro's number.
Which is 6.02 times 10 to the 23rd power.
Correct. So 12 times 6.02 times 10 to the 23rd power equals, so just do 12 times 6.02 to start out with.
72.24. 72.2.
So 72.2, this will be molecules. Well, actually, we're times 10 to the 23rd molecules. The only problem is if we're doing scientific notation, we have to make sure there's only one number in front of the decimal. So we'll move this over. So that makes it 7.22 times 10 to the 24th. Particles are going to be one of the easier ones to do because all you're having to do is use that Avogadro number,
Wait, so
just as long as you have scientific notation.
7.22 times 10 to the 23rd. Because you changed it.
It's to the 24th now.
Oh, okay. But do you still put molecules?
You can put molecules of this, but as long as you have it there, I really don't care. You're just doing the number of particles. As long as you understand what the particles are, that's what matters. All right, let's go with... Yeah, let's do 8. No, we've done... Yeah, let's do 8, because it's a 2-step. So, we have to get from grams to molecules. So that means we're going from here to here. So we will get the mass.
Divided by the molar mass.
Correct.
And then multiply it.
And then you'll multiply it by Avogadro's number. So molar mass is SI, which is 28.1. So 28.1. You have sulfur, which is 32.1. So that's times 2. That'll make it 64.2. So add these two together. What do you got?
92.
So these numbers represent these masses. So you just add these two together, and it's going to be 92 what? 92.3. So you will divide this number by 92.3. And this gets our moles. 0.7. So 0.7 moles. Now we're going to multiply this by our Avogadro's number. What do we get? 0.7 times 6.02. 4 point what? 4.2. And this is going to be times 10 to the 23rd molecules. Avogadro's number is always 6.02 times 10 to the 23rd.
I can't read. To the 23rd? She
Correct.
can't read it.
That's all right. It's on your map. So if you go from here, you see that this is your Avogadro's number. You're multiplying it. You're dividing it by that. If you're trying to get from there to there. All right. Let's go to the back side. So let's focus a little bit.
Because they're going to be like, oh my god, are you kidding me?
I can't zoom in anymore because I don't have the ability to zoom. Sorry. I'm going to post this video on Classroom after we're done. Yeah. Alright, so determine the volume of liters occupied by 0.03 moles of gas. So it doesn't matter what the element is in this case. We're just going from moles to liters. So that means we have 0.03 moles
22.4.
times 22.4. And the answer is
0.7.
0.7?
Yeah.
Alright. So 0.7 liters of this gas. Now that we have this, let's do a double step one. Yeah. We can do 6.
The heck?
Or we can let's do 7, because that goes from mass to liters. So nitrogen is what we're working with. Remember, if it's nitrogen gas, it always is N2. So if we look at nitrogen, we have 14. So 14 times 2, 28. So you'll divide this by 28 to equal your moles. 14 is half of 28, so that makes this one easy to do, as I read the wrong thing. So 1/2 mole of NO2 or N2. So that's going to be, to get to our volume, what do we have to do? If we're going from moles to volume? Right, so we go look at this. If we go from moles to volume, we multiply by 22.4. So times 22.4 liters, 11.2 liters of N2. And that's simple.